Okay, guys, so let's go over some of this. So the first question somebody asked was, how do I identify strong acids versus weak acids? Okay, so the strong acids, you just have to know. It's just a matter of memorization. So HCl, HBr, HI, HNO3, H2SO4, and HClO4. So we get hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, and perchloric. Okay, so those are all your strong acids. Everything else is weak. All other acids are weak acids. So, weak examples that you'll see: HF, HCN, H3PO4, I don't even know, HNO2. Okay, these are all weak, and there are other ones as well. Acetic is a big one. Okay, so those are all weak acids. There are more, but those are all the weak acids. These are the only strong acids. As far as strong bases, so those are all your hydroxide containing bases. So usually like group 1 and 2 metals with a hydroxide. So sodium hydroxide, lithium hydroxide, calcium hydroxide, potassium hydroxide. Those are usually what you'll see. Weak bases are usually nitrogen containing bases. So ammonia, something like that with like a different side chain off of it. So those are your weak bases. All right, so your hydroxide containing bases are the strong ones. And that's pretty much it. So you just got to know it. And then how to identify water as an acid or a base. So water will be whatever it has to be in order to make the reaction happen. So if it's with an acid, it's going to be a base because that's how the reaction happens. If it's with a base, it has to be an acid. So let's say you have this imaginary fake acid and you add it to water. And so acids like to donate, so he's going to give the hydrogen to water, and so we have A- plus H3O plus. Okay, so now for identifying this, since this one was the donor, and this, you can't see, since this was the donor, and this is the acceptor, he's got to be the acid, he's got to be the base. On the other side now, since he was the acid, since A- was actually part of the acid in the beginning, now he's the conjugate base, and H3O plus is your conjugate acid. Alternatively, if you had a basic reaction, let me just erase this quick. I'll make space here. So if you had a base, like we were just saying, say you had an amine. Okay, so since this is a base, he accepts. The water would donate because that's how he works. Okay, so now this guy is your base. Water is now the acid because it has to be. Ammonium was ammonia but gained a proton, so now he's the conjugate acid. And now OH minus is your conjugate base. Hydroxide will always be a base. It can never be an acid. Hydronium will always be an acid. It can never be a base. So that's just something that is good to know. Usually if there's a positive charge, 95% of the time, that's the acid. If there's a negative charge, again, most of the time, that's the base. It's not 100%, but you can kind of double check your work. So as far as like what water is anything that it has to be. If it's with an acid, your water will be a base, and if it's with a base, then the water will be an acid. Okay, the last question someone asked about was converting pH to all the other things. All right, so I'm going to go through POH, concentration of H plus, concentration of OH minus. Okay, the easiest one is to go from pH to POH. So I'm going to take, I know that POH is going to be 14 minus pH, because that's the relationship. So I know that 14 minus 3.4 is going to be 10.6. And that, my friends, is my POH. So that's an easy one. You can do that going from pH to POH or the other way around. You just do 14 minus the other one. Okay. Now we need to find the concentrations. So if I'm going from pH or POH to concentration, or POH going to OH minus, I have to use this little button on my calculator. So it's essentially the second log button. Okay, when it comes up on your calculator, it will be 10 carat is what it looks like. So that second log, or the inverse log, is what you need, and then you're gonna put your negative pH in there. Okay, so for this one, I would do second log, which is 10 to the negative 3.4. And if I do that, I get about 3.98 times 10 to the minus 4 molar. That is my H plus concentration. Okay. Now to go to OH minus, I have two choices. I can use my POH and do the same thing I just did with pH, or I can use my H plus that I just calculated. So I'm going to do both. So let's say I use my POH, so I know that 10 to the minus POH is going to be my OH minus concentration. So I'm going to say 10 to the negative 10.6, right? Because that was my POH above. And that is the second log again. And I get 2.51-ish times 10 to the minus 11 molar. The other way is to use Kw, which is our constant for our water dissociation. And I'm going to put H plus underneath. Okay, so you're always going to divide the one that you know, or divide Kw by the one that you know, and that's going to be OH minus. All right, so Kw is always, this is a constant, you will have this 10 to the minus 14. My H plus concentration was 3.98 times 10 to the minus 4. So if I do that calculation, I get same thing. So either way you get the number, it's just whatever is easier for you to do in your calculator. Okay? If we were going the other way, there's only one that I didn't cover here, so I'm going to erase. Sorry, I'm just going to erase this quick. And I'm going to use a different color, although I do like blue. Okay, let's say we have H plus and we got to go to pH. That one, you're doing negative, then the log button, and whatever your H plus concentration is, which I just erased like a genius. It was 3.98 times 10 to the minus 4. Okay? If you do that, you should get 3.4 as your pH. Okay? So to go from concentration to pH, you're going to use the negative log. Negative log of the hydrogen ion concentration is a pH, that's its definition. And if you're going the other way, that's when you use the second log function of whatever you got. So I hope that helps. Those are the only questions that I got. So I think you'll be good. I'll talk to you later, guys.